4.4 vectors. Vector is a special number which has magnitude, which is like 1, 2, 3, 4, 5, and direction. For example, we want to use vectors when we describe forces, when we describe, for example, how the wind is blowing. So something for which it's important to have a number and direction in which this number is applied. We draw vectors as arrows. This point is called initial point of the vector, and this point is called terminal. And this one is terminal. Usually we are going to put some letters to kind of label the points. For example, I put initial point P and terminal point Q. We're going to write down the vector as PQ. We're going to put a little bar in it. And what is going to be the magnitude? Magnitude is just you take a ruler and measure how long is the vector. For example, vector is 5 units or 3 units. Direction is going to tell you like which way it points. Can point up, can point like down, left, right, something like this. So magnitude and direction. Two vectors are equal if they have same magnitude and same direction. Does not matter that they sit at different points. For example, I'm going to draw my vector V, totally different name, and sits at a different part of the board, but magnitude and direction are same, so I'm going to say that vector PQ equals vector V. Okay, so what operations are we going to perform on vectors? Actually, all operations we do on numbers, but because vectors have actually like two quantities, direction and magnitude, are going to be slightly more operations. We are going to start with vector addition. So to add two vectors, we do have two ways to do this. Way number one is going to be a triangular way. For example, somebody gives you vector B and vector A, and they're asking you, what is going to be vector C, which is equal vector A plus vector B? What is going to be vector C? Okay, what are we going to do? We're going to copy vector A, and then from the terminal point of vector A, draw vector B. Just copy it same way. And we are going to connect initial point of vector A and terminal point of vector B. And that's going to be a resulting vector C. So that's one way to add vectors, to build a triangle, put them in a like head to tail and make up a triangle. Way number two is called parallelogram. Parallelogram, it's kind of inclined rectangle, right? How it works. For parallelogram, we are going to copy same vectors, A and B, but we are going to place them from the same point, like I'm doing right now. I'm going to start them from the same point. What I'm going to do, I'm going to build parallel line which goes through the terminal point of vector B and parallel line which goes through the terminal point of vector A. You see that two parallel lines as sides, two parallel lines as sides are making a parallelogram. Now I'm going to build a diagonal which goes from initial point of B and A, and terminal point is going to be kind of opposite vertex. And that's going to make up vector C. See, two ways to add two vectors. In both cases, vector C is a sum of vectors A and B. What is interesting, if you compare these two pictures, or like over here, instead of dashed line, draw a vector, you're going to see this vector is exactly the same as vector B. It has same magnitude and same direction because it's parallelogram. Parallelogram has two parallel lines and the sides are equal. So that's actually vector B. If you now consider a triangle over here, it's going to look exactly like this one. So actually both ways are going to give you same result just because they are doing same operation. It just, the operation does look differently, but it's exactly same operation. Okay, now let's move to subtracting vectors. I'm going to erase everything. How do we subtract vectors? Before we start subtracting vectors, let's define a negative vector. Negative vector. Well, negative vector is minus vector V. So what is going to be true about this vector V? Imagine that we do have vector V looking like this. So minus vector V is going to be exactly vector V looking at opposite direction. Same magnitude, same direction, just like opposite direction. So they're going to be parallel, but opposite directions, V and vector V. how it's going to help us to do subtraction. Well, for example, somebody gives you two vectors A and B, vector A, vector A and vector B, and somebody is asking what is a vector C, which is A minus B. And what are we going to do subtraction? We are going to use the fact that minus B actually can be treated as negative B vector. Now we are just going to use addition rules, and instead of vector B, use vector negative B. So what I'm going to do? Well, I'm going to use a parallelogram way to add vectors. I'm going to copy vector A, then I'm going to copy vector B from the center, vector B, from the same initial point. Then I'm going to continue the line over here and measure vector B and copy it in opposite direction. This is going to be vector negative B. Very easy to do. Now I'm going to build a parallel line here and parallel line here to make a parallelogram. And my vector C is going to make up, again, diagonal of this parallelogram. That's going to be vector C. Okay, well, that's how I usually do subtraction. It's easy to remember, nothing new, right? That's just addition with negative vector. Well, some other people suggest to still use a triangular way. How? If I connect this terminal point of vector B and terminal point of vector A with vector over here, you're going to see that this vector is also vector C, just because its two lines are parallel and the magnitude is same because it's parallelogram. So actually, if you wish to subtract two vectors, you can draw them from the same origin and make a third side of the triangle. Just remember that the initial point is going to be at B and the terminal point at A. Well, I don't know which way you like. We're not going to add lots of vectors graphically. So eventually we are going to develop algebraic way to add vectors. Graphical way is not very precise. Okay? Now, let's move to, we know how to add, we know how to subtract, let's move to multiplication. So, multiplication with vectors is more complicated than with numbers, because for numbers you basically just kind of multiply 2 by 3. How do we multiply 2 by 3? Well, we actually add 3 two times, right? 3 two times, that's going to be 2 by 3, and that's going to be 6. So the idea is that this 2 actually means that there are 2 3s to add, and you put it like 2 over here and get 6. What are we going to have with vectors? Well, with vectors, we're going to have two ways to multiply. Way number 1, we are going to study in this section. Way number 2, in next one. So, way number 1 is a scalar multiplication. What is scalar multiplication? First, what is scalar? Scalar is just a number without direction. Vectors are numbers and directions. Scalars are just numbers like -1 or 2 or whatever, like any numbers can be square root of 2. Does not matter that they are negative or positive, because this does not mean direction. It means direction in one-dimensional world, but in two-dimensional world we are dealing with vectors. Does not mean direction actually. So, what is a scalar multiplication? Imagine somebody sets up a scalar A and gives us vector B. To multiply A by vector B, we are going to kind of use the same rule we have over here. We are going to add vector V A times. Well, let me do it on a simple kind of multiplication. Let's imagine 2 multiplied by vector V. 2 multiplied by vector V is going to be V plus V. So the resulting vector is going to be 2 times longer than V and have same direction. I'm going to just draw it. Imagine that this is vector V, and if I do 2V, so it's V, and that's going to be the resulting vector. V, V, and this is vector 2V. What happens if the number is not natural number? Is it not 2, not 3, but something called 1.5? Same idea. You just increase the size of vector V by the number, or magnitude by the number which sits in front. So for example, it's 1.5, so you are not measuring 2 vectors V, but 1 vector V and half of the vector V. And for smaller than 1 unit numbers, same. So that's going to be scalar multiplication. What is going to happen if we have a negative vector and we want to multiply it, something like -2V? How this multiplication is going to work? This multiplication is going to work like this: negative V plus another negative V. We're kind of having 2 negative V vectors. Well, how the vector is going to look? First we build negative v, that's negative v, and then we build one more negative v, and the resulting vector is going to look like this. So my negative v vector looks like just normal 2v vectors in opposite direction. That's multiplication. We see that magnitude is going to be twice longer, direction is going to be opposite if we have negative number. Now, graphical way of writing vectors is a little bit imprecise because, well, some people graph very good, some people don't know how to graph well, and we are going to develop eventually an algebraic way to write vectors. Before we do this, we are going to introduce position vector. What is position vector? Position vector. Well, imagine that somebody gives you a vector in a coordinate plane. I'm going to first set up the coordinates of point P and the coordinates of point Q. Sorry, P is not a vector, P is just a point. So coordinates of point P are going to be 3, 4, and coordinates of point Q are going to be 5, 5. So this is initial point, that's final point. So I'm going to graph it 1, 2, 3, 1, 2, 3, 4, 4 here, 3 here. So that's my point P. And then my point Q is 5 and 5. So somewhere here. So that's going to be my vector PQ. You see that to set up a vector, you will need two pairs of numbers. Pair of number, which is like 4 number, and that's a lot. What I can do, guys, I can take this vector and move it to origin and build the very same vector from the origin. And that's what I'm going to do. A vector from the origin. Well, it doesn't look like the same because I did it much longer here, not 5. I think 5 is going to be somewhere here. Just move the vector to the origin. Vector which you move to the origin is going to be called position vector. I'm going to label it as V. V is position vector. Vector which starts from origin is called position vector. What is good about position vector? All position vectors start at origin, which means that you basically can just understand this and you don't need to give 0, 0 every time as initial point. You just label it as final point. Now the question is how to calculate this final point, how position vector is going to look. Well, what is idea of how to define position vector? For example, for this one. Well, what we need to do with this point to move it to origin. First, in x direction, we're supposed to move it 3 units to the left. Means that subtract 3 from x, right? In y direction, we're supposed to move it 4 units down. 4 units down is subtract 4. Subtract 4, I'm going to do it. So point P is going to be moved 3 minus 3, 4 minus 4, and that's becoming point 0, 0, right? Point Q is going to become 5 minus 3 and 5 minus 4, and they're going to become point 2, 1. You see that because my point P moved to origin, my point 2, 1 is going to mean the terminal point. For position vectors, we are going to invent a different way to kind of give their coordinates. Instead of writing just terminal point like 2, 1 as coordinate, we're going to put a special brackets and we're going to put 2, 1. Sorry, 2, 1. So what do we subtract here? You see that we are subtracting exactly initial point from final point. That's going to be the way to find actual position vector. Let me kind of do an example of finding position vector. So first, I'm going to put example, and you try to do it. If it does not work, I'm going to help you. Somebody gives me coordinates of 2 points. Initial point of a vector P1 has coordinates -1, 2, and the terminal point has coordinates 4, 6. And they're asking, can you find position vector? Position vector. Well, use the idea I have over here. Try to find it on your own. I'm going to count to 5 and do it myself. And you can check your solution. So 1, 2, 3, 4, 5. So what is going to be position vector? I'm going to take terminal point 4 minus initial point -1, 6 minus initial point 2, and I'm going to get 5 over here and 4 over here. That's going to be my position vector, 5, 4. Okay. So the idea is to subtract initial coordinates from final. Now let's move to like which vectors are equal and how to add vectors. So let me erase all this stuff. Two vectors are called equal if their position vectors are equal. What does it mean? Somebody is drawing vector PQ over here. PQ. Somebody is drawing vector, I don't know, MN over here. Sorry, MN. Are they equal or not equal? Two vectors are called equal if their direction and magnitude is equal, right? If we graph both of them from origin, they must be the same vector if they're equal. So if PQ equals MN, they must be like PQ, and if you graph it from origin like MN, they're supposed to give you the same point, MN. So what does it mean for us? Well, first, why does it happen? Because if they are parallel, they're going to be on the same line here, just because there are not two parallel lines which go through the same point. We break axiom of geometry, right? If they have same magnitude, also there is only like one point which is the same distance from some other point. That comes from geometry. Now, what does it mean for position vectors? If position vector PQ equals AB and position vector MN equals CD, then A is supposed to be equal to C and B is supposed to be equal to D, if those two vectors are equal. So this way we're going to say that PQ equals MN. Position vectors must have same coordinates. Okay? Now, there are two special vectors in the world of two-dimensional vectors, and they're called basis vectors. Imagine that we build a vector over here which starts at 0 and ends at 1. I'm going to give it a special name, vector I. What is going to be position vector of vector I, which is actually a position vector? Well, the coordinates of this point is 1, 0. If you graph position vector in vertical direction, same idea, coming from origin to the point 1, label it as vector J. It's going to have the coordinates 0 is x and 1 is as y. These two vectors are called basis vectors. Why? Why are these two vectors are important? What is going to happen if I add 2i vectors plus 3j vectors? Well, what kind of vectors I'm going to have? I remember that if I have 2i vectors, I have to do I and I, right? My final point is going to be 2 over here, so vector is going to look like 2, 0. 3j vectors, 1, 2, 3, is going to look like 0, 3. If I add these two vectors, like point, like coordinates, I'm going to have 2, 3. So actually I'm going to have the very same numbers here as position vector. So what is going to happen geometrically if I add 2i plus 3j? Well, if I'm using parallelogram way, let me erase this black and p vector. I'm going to have what? Parallel line, and that's exactly the vector which is going to be sum of these two vectors. And what these two numbers are going to describe the terminal point, or that's a way to add vectors actually. Now we are going to set it up like more mathematically. Imagine that you have vector v with coordinates or like terminal point AB and vector w with terminal point CD. Each of them can be represented as AI plus BJ, and W can be represented as CI plus DJ. Well, same way we have it over here, like the first number comes in front of I and the second number comes in front of J. Now, if I want to add these two vectors, what I'm going to do? Well, I'm just going to add them expressed through basis vectors. So I'm going to write down V plus W equals AI plus BJ plus CI plus DJ. I'm going to combine vectors with I together. So A plus CI plus B plus DJ, and then I'm going to just convert them into the form of like bracket. So I have A plus C, B plus D. So you see, we are going to, we just got an easy way to add two vectors. You just need to add the coordinates or like components of the vectors, like x components together and y components together, and you're going to get the sum of two vectors. Let's consider a couple of examples. So I'm going to add some vectors. Let's add vector 1, 3 and vector 4, negative 1. I'm going to add x coordinates, 1 plus 4, and y coordinates, 3 minus 1. Yeah, this one has minus, so we're going to actually subtract it. The resulting vector is going to be 5, 2, right? What is going to happen if I want to subtract these very same vectors? Well, I'm going to first pull minus inside and have 1, 3 plus minus 4, 1, and then just add them as I was doing it. 1 minus 4, 3 plus 1. That's going to give me negative 3, 4. Do you need to manipulate with minus like this? No, you just can actually subtract 1 minus 4 and 3 minus negative 1, which is going to give you 3 plus 1. So this intermediate step is not necessary. Do you need to do this stuff all the time? No, you just can use the rule of adding the coordinates. Okay? Okay, now our next thing to define is magnitude of vector v. How do we find how long is vector v? If somebody gives us position vectors, sorry, my body is moving a little bit. Imagine somebody gives us position vector, and position vector looks like A, B. How do we find magnitude? First, how do we write down magnitude? Magnitude of vector v is denoted as vector v in these bars. What is magnitude? It's just length of vector v, like 5 units, 3 units, or whatever. How do we find it? Let's graph first how vector v is going to look. Vector v is going to look like this, right? What we are searching for these lengths. What are these A and B? This A and B are going to be the coordinates, well, x coordinate and y coordinate of vector v. So, what does it mean? This side is equal B, and this side is equal A, and what we have actually a right triangle. In right triangle, we can use Pythagorean theorem. We can write down that the magnitude of vector v squared is equal A squared plus B squared, right? Or magnitude of vector v equals a square root of a square plus b square. That's a formula for finding magnitude. Let's calculate magnitude of vector 1, 3. So magnitude of vector 1, 3 is going to be a square root of 1 square plus 3 square, which is going to be a square root of what? 1 plus 9 is 10, square root of 10. Okay, so magnitude of the vector is just a square root of squares of coordinates. What is unit vector? Well, what is idea of unit vector? Unit vector is a vector of length 1 unit. Can be in any direction, but the length is supposed to be 1 unit. 1 centimeter, 1 meter, 1 kilometer, but just 1 unit. How do we find the unit vector? The formula for unit vector is going to look next. You take vector v and divide it by the length of vector v, or magnitude of vector v. And the vector you're going to get is going to be a unit vector. What I'm going to do, I'm not going to prove it in general. I'm going to show it on the vector we just had. Remember, vector v we just had coordinates 1 and 3, and the magnitude of vector v was a square root of 10. So if I apply the formula, I'm going to get a vector which is 1, 3 divided over magnitude which is 10. Which is going to give me 1 over square root of 10 and 3 over square root of 10. What I'm going to do, I'm going to find magnitude of vector u using the same formula I was using for v. Square root, I'm going to square this, 1 over square root of 10, and I'm going to square this, 3 over square root of 10. So what I'm going to have under the square root is 1 over 10, square root is becoming just 10, and here I'm going to have 3 squared is 9, and the square root of 10 squared is 10. So I'm going to have actually 10 over 10 because 1 plus 9 is 10 and the denominator is the same, which is 1. So yes, the magnitude of unit vector is equal to 1. So if I obtain the unit vector this way, I'm going to get 1. Okay? Okay. What is interesting about unit vector? We can use unit vector to actually set up vector without directly showing the coordinates of endpoints. The formula for unit vector, as you remember, looks like this. V, vector v, divided over length of vector v. If I multiply by length of vector v on both sides, length of vector v and length of vector v, I'm going to get that vector v can be obtained as length of vector v multiplied by a unit vector. So basically what I did over here, I separated direction and the length of vector in two different factors. This is just pure length of vector v, like 5 units. And unit vector is going to tell you in which direction your vector looks, without telling the magnitude. Okay? The last thing we are going to learn is called direction angle. Direction angle. What is direction angle? Well, if you graph vector v from the origin, you're going to see that it makes some angle with positive direction of x-axis. We are going to call this vector, or let's call it alpha actually. We are going to call it direction angle. Direction angle. Direction angle is supposed to be between 0 and 2 pi. Okay? So maybe not 0 degrees if I'm using radians. So it's from 0 to 2 pi. We're not going to allow it to go like negative or whatever, like more than 2 pi makes no sense a lot, right? Let's find direction vector, direction angle for some vector. Let's imagine that I'm giving you coordinates of a terminal point 2 and 2. What is going to be the angle here? Well, this is 2 and this is also 2, right? So V equals 2, 2. How do I find alpha? I can use trigonometric function of tangent of alpha and write down that its opposite side over adjacent, which is 2 over 2, gives me 1. So tangent of some angle equals to 1. The angle then, that's the angle value, equals pi over 4. That's my direction angle, pi over 4. Kind of easy to find. Usually, guys, if we deal with vectors in physics or science, usually you're not going to be given the coordinates of vectors. Usually you are going to be given like some angles or directions and magnitudes. So let's try to solve the problem. Let's try to find out how the vector looks if somebody gives us magnitude and direction. So we're kind of solving inverse problem. Imagine that somebody gives us a vector v and tells magnitude is 5 and direction angle is 30 degrees. Can you actually find the position vector? Well, I'm going to draw the picture, but actually it's not necessary. So we know that this length is 5. We know that this is 30 degrees. What we need to know? We'll need to know x here and y here. Well, again, we are going to have a right triangle, right? So x is adjacent side. You will remember that adjacent side equals hypotenuse 5 by multiplied by cosine of the angle, which is going to give us what? Cosine of 30 degrees is square root of 3 over 2. Still remember our table, so it's 5 square root of 3 over 2. And y, opposite side, is going to be hypotenuse multiplied by sine of 30 degrees, which is 5 multiplied by 1/2. Sine of 30 degrees is 1/2. And that's going to be 5 over 2. So because we do know coordinates of this point, we can put them as a point for position vector. 5 square root of 3 over 2 and 5 over 2. That's going to be my position vector. Well, we can simplify it a little bit, but not necessary. Okay, that's all about vectors. Please do your homework. And if you have any questions, email me. Thank you.